Chapter 4. The Birth of the Ice Age Theory. In 1836, Louis Agassiz, a young Swiss naturalist, went with Professor Jean Charpentier, another naturalist, to an alpine glacier to demonstrate to him the fallacy of the new idea that an ice sheet once covered a large part of Europe. 4 years before, a teacher in a small town forestry school, A. Bernardi, had written, "Once the polar ice reached as far as the southern limit of the district, which is still marked by erratics." A botanist had come upon the same idea, probably independently, and coined the term diizeite. He had succeeded in winning Charpentier to the hypothesis. At the edge of the glacier, Agassiz, who came as a skeptic, was himself converted. He became the chief apostle of the new theory. He built a hut on the glacier of R and lived in it so that he could observe the movements of the ice, and thereby attracted the attention of naturalists and curiosity seekers all over Europe. The study of the glaciers in the Alps revealed that the glacial ice may move by its own weight a few feet daily. It actually transports stones by carrying and pushing them. Okay, so it does do that too. Some are pushed by advancing front of the ice to form terminal moraines. When the glacier melts and retreats, the loose rocks remain where they were at the time of the greatest expansion of the glacier. Agassiz assumed that the erratic boulders in the Jura Mountains had been carried there by ice from the Alps, and that the trains of boulders in northern Europe and America had been formed by gigantic glaciers that in the past covered large parts of these continents. He also concluded that the drift had been brought and left by the ice sheet. Ice scratched the underlying rock with the help of flint and other fragments of hard stone. It retained in its grasp, and it polished the rocky floors and slopes and valleys, and excavated the beds of lakes. Agassiz made his conclusions with respect to the other parts of the world on the basis of observations limited to Switzerland and its surroundings. He thought that if he could convert two of the leading geologists, Buckland, the author of Reliques de Louvain, and Murchison, to the Ice Age theory, and thus win their support, the task of gaining recognition for it would become much easier. Agassiz went to the British Isles. In later years, as his widow described it, recalling the scientific isolation in which he stood, opposed as he was to all the prominent geologists of the day. He said, "Among the older naturalists, only one stood by me, Dr. Buckland, Dean of Westminster. We went first to the Highlands of Scotland, and it is one of the delightful recollections of my life that as we approached the castle of the Duke of Argyll, standing in a valley not unlike some of the Swiss valleys, I said to Buckland, 'Here we shall find our first traces of glaciers.' And as the stage entered the valley, we actually drove over the ancient terminal moraine, which spanned the opening of the valley. It was a setting for a revelation. Agassiz won a follower." A few weeks later, on November 4th, 1840, Agassiz read a paper before the Geological Society of London, summarizing the excursion in light of the Ice Age theory and Buckland, who was then president of the society, followed by a paper of his own on the same subject. Even before meeting, he had written to Agassiz of the success of his missionary work. "Lyell has adapted your theory in total!" On my showing him a beautiful cluster of moraines within 2 miles of his father's house, he instantly accepted it, as solving a host of difficulties that have all his life embarrassed him. Lyell, too, agreed to read a paper less than 3 weeks after this episode, on the day following the Agassiz and Buckland lectures. In this paper hastily prepared, he explained the moraines in Great Britain in the light of Agassiz's teachings. At the November 4 meeting of the Society, Murchison attempted an opposition, but in the words of Agassiz, did not produce much effect. He added, Dr. Buckland was truly eloquent. That same year, 1840, Agassiz published his theory in a work entitled Etudes sur les glaciers. He wrote, I'm sorry if I butchered that, the surface of Europe previously adorned with tropical vegetation and populated by herds of huge elephants, enormous hippopotami, and gigantic carnivora, was suddenly buried under a vast mantle of ice, covering plains, lakes, seas, and plateaus. Upon the life and movement of a vigorous creation fell the silence of death. Springs vanished, rivers ceased flowing. The rays of the sun rising up this frozen shore, if indeed they reached it, encountered only the breath of winter from the north and the thunder of the crevices as they opened up across the surface of this icy sea. Agassiz regarded the inception and the termination of the Ice Age as catastrophic events. He believed that mammoths in Siberia were suddenly caught in the ice that spread swiftly over the larger part of the globe. He expressed the belief that repeated global catastrophes were accompanied by a fall in the temperature of the globe and its atmosphere, and that glacial ages, of which the Earth experienced more than one, were terminated each time by renewed igneous activity in the interior of the Earth. Eruptions de interior. Thus, he maintained that the Western Alps had risen up recently, at the end of the last ice age, and were younger than the carcasses of mammoths in Siberia, the flesh of which is still edible. These animals, he thought, had been killed at the beginning of the Ice Age. With the renewal of igneous activity, the ice cover melted. Great floods ensued, and the mountains and lakes in Switzerland and in many other places were formed, and the relief map of the world was generally changed. Come on, man. It is often said that Agassiz added from 500,000 to 1,000,000 years to the recent history of the world by inserting the Great Ice Age between the territory or the age of mammals, and the recent comprising the late Stone Age and historical times. It should be borne in mind, however, that the 1,000,000-year span for the Ice Age is Lyell's estimate, and he interpreted Agassiz's theory in the spirit of uniformity. The theory of a continental ice cover was acceptable to Lyell. He agreed to it, satisfied to go no farther. For his proof, then, 2 miles from his home. He realized that the floating icebergs could not explain the phenomenon of drift and erratic boulders in all places. The only alternative had been the waves of translation, or tidal waves, traveling on land, but this was outright catastrophic. Now, with the continental ice age theory, he felt he had the correct solution if the catastrophic aspect of the theory, as originally suggested by Agassiz, a follower of Cuvier, was eliminated. It was not yet asked what produced such a cover. End of subchapter. On the Russian plains. Soon after the historic meeting, at which the Ice Age theory was accepted by the majority of the members of the Geological Society, R.I. Murchison went to Russia, where he had been invited by Tsar Nicholas I to make a geological survey of the empire. Out of this survey grew recognition of the Permian system, the Permian-Silurian, and the Devonian. Also, first recognized by Murchison, Devonian, in collaboration with Sedgwick, constitute 3 of the great divisions in the modern concept of early geological ages. For many months, Murchison crossed the latitudes and longitudes of Russia, carefully observing the erratic boulders strewn over the great Russian plains, and rechecking the validity of Agassiz theory. In Finland and northern Russia provinces, he found very large blocks, but they diminished in size the further south one went. which pointed to the action of water. A tide that came down from the north or northeast, spreading rock fragments along its way. He also observed that erratic boulders in the Carpathian Mountains were not of local but of Scandinavian origin. Of the drift, or the piles of stone, sand, clay, and gravel, which are spread out in such enormous masses over the low countries of Russia, Poland, and Germany, Murchison expressed the conviction that a vast portion, by far the greater part, has been transported by aqueous action, consequent of powerful waves of translation, of currents occasioned by relative and often paroxysmal changes of the level of sea and land. Paroxysmal changes, that means sudden, violent, in case you wondered, of the level of sea and land, whatever may have been the cause of the eruption of the sea. Such aqueous debacles, with the help of ice flows, produce the drift. Seeing that there are no mountains whatever from which a glacier can ever have been propelled in southern Sweden, Finland, or northeastern Russia, and yet that these regions are powerfully abraded, scored, and polished, Murchison came to the conclusion that effects so extensively developed over such flat countries must have resulted from an erupting sea that also left behind enormous masses of debris and rolled stone. Murchison rejected the application of the terrestrial glacier theory of Sweden, Finland, northeastern Russia, and the whole of northern Germany. In short, to all the low countries of Europe. He agreed that in mountainous northern Scandinavia and Lapland, Arctic glaciers formerly did exist. Ice flows descending from these glaciers carried angular broken stones over land covered by sea and dropped them on top of the drift created by the eruption of the sea. Murchison called attention to the fact that Siberia is entirely free from erratic blocks, though environed on three sides by high mountains. He required the aid of icebergs detached from the glaciers to account for certain superficial phenomena, but he confidentially maintained that aqueous detrital conditions will best account for the great diffusion of drift over the surface of the globe, and at the same time explain the very general striation and abrasions of the rocks, at low as well as high levels in numerous parallels of latitude. In his later years, Murchison, without retracting any of his observations and conclusions made in Russia, and admitted in a letter to Agassiz that he regretted his early opposition to the Ice Age theory. On the other hand, marine deposits of recent age were found in large areas of European and Asiatic Russia. Caspian Sea, which stretches between southern Russia and Persia, live seals related to the seals of the Arctic Ocean. It is concluded that the polar sea spread and established a connection with the Caspian Sea, and this in recent time. Since ice withdrew, the Arctic Ocean has spread over large areas of northern Russia, and in many places has left marine deposits on the glacial drift as well as on the firmer rocks. The Arctic water spread also over the Obi Basin far to the south, and established connections with the Caspian Sea, at which time the progenitors of the present seals of the Caspian Rocky Islands migrated thither to become stranded when the waters withdrew. Ice Age in the Tropics. In 1865, Agassiz went to the equatorial Brazil, one of the hottest places in the world, where he found all the signs he ascribed to the action of ice. Now, even those who had previously agreed with him became distressed. An ice cover in the tropics, on the very equator, there were drift accumulations, and scratched rocks, and erratic boulders, and fluted valleys, and the smooth surface of tillite, rock formed of consolidated till. So there must have been ice to carry and polish, and the region must have gone through an ice period. What could have caused a tropical region to be covered by ice several thousand feet thick? Abundant vestiges of an ice age were likewise found in British Guiana, another of the hottest places on Earth. Soon the same word came from equatorial Africa, and what appeared even more strange, the marks there indicated not only that equatorial Africa and Madagascar had been under a sheet of ice, but that the ice had moved, spreading from the equator toward the higher latitudes of the southern hemisphere, or in the wrong direction. The vestiges of an ice age were discovered in India, and there, too, the ice had moved from the equator, and not merely toward higher latitudes, but uphill, from the lowland up the foothills of the Himalayas. On reconsideration, the vestiges of ice in equatorial regions were ascribed to a different ice age that had taken place not thousands, but many millions of years ago. Today, the glacial phenomena in the tropics and in the southern hemisphere are ascribed in the main to the Permian Age, a much earlier period than the recent Ice Age. The most remarkable feature of the Permian glaciation in its distribution, writes C.O. Dunbar of Yale University, South America bears evidence of glaciation in Argentina and southeastern Brazil, even within 10 degrees of the equator. In the northern hemisphere, peninsular in India within 20 degrees of the equator, was the chief scene of the glaciation, with the ice flowing north or from the tropics to higher latitudes. The ice cap covered practically all of southern Africa up to at least latitude 22 degrees south, and also spread to Madagascar. Even if the phenomena took place very long ago, an ice covered thousands of feet thick in the hottest places of the world is a challenging enigma. R.T. Chamberlain says, some of these huge ice sheets advanced even into the tropics, where their deposits of glacier-borne debris, hundreds of feet in thickness, amaze the geologists who see them. No satisfactory explanation has yet been offered for the extent and location of those extraordinary glaciers. Glaciers almost unbelievable because of their location and size, certainly did not form in deserts. End of subchapter. Greenland. Greenland is a contemporary example of what, according to the Ice Age theory, happened to a large part of the world in times past. Greenland belongs to the great archipelago that crowns northeastern Canada, though it is sometimes regarded as a part of Europe. It is the largest island in the world, if we consider Antarctica and Australia as continents. The island is 1,660 miles long, largely within the Arctic Circle, reaching the northern latitude of 83 degrees 39. Of its 840,000 square miles of surface, over 700,000 are covered with an immense mountain of ice that leaves free only the coastal fringes. The thickness of the ice is measured by listening to the echo that comes back from the bedrock when a detonation is set off on top of the ice. It is found to be over 6,000 feet thick. For a long time, it was the belief of many that a large region of the interior of Greenland was free from ice, and was perhaps inhabited. It was in part to solve this problem that Baron N.A.E. Nordenskjöld set out upon his expedition of 1883. He ascended the ice cap from Disco Bay, latitude 69 degrees, and went eastward for 18 days across the ice field. Rivers were flowing in channels upon the surface like those cut on land, only that the pure blue of the ice walls was, by comparison, infinitely more beautiful. These rivers were not, however, perfectly continuous. After flowing for a distance in channels on the surface, they, one and all, plunged with a deafening roar into some yawning crevasse, to find their way to the sea through subglacial channels. Numerous lakes with shores of ice were also encountered. On bending down the ear to the ice, wrote the explorer, we could hear on every side a peculiar subterranean hum, proceeding from rivers flowing within the ice, and occasionally a loud single report like that of a cannon gave notice of the formation of a new glacier cleft. In the afternoon, we saw at some distance from us a well-defined pillar of mist, which, when we approached it, appeared to rise from a bottomless abyss, into which a mighty glacier river fell. The vast roaring water mass had bored for itself a vertical hole, probably down to the rock, certainly more than 2,000 feet beneath, on which the glacier rested. The Ice Age survived in Greenland. This Arctic island reveals how vast continental areas looked in the past. However, it does not explain how ice could have covered British Guiana or Madagascar in the tropics. And what is no less surprising, the northern part of Greenland, according to the concerted opinion of glaciologists, was never glaciated. Probably then, as now, an exception was the northernmost part of Greenland, for it seems a rule that the most northerly lands were not, and never were, glaciated, writes the polar explorer Wilhelm Stefansson. The islands of the Arctic archipelago, writes another scientist, were never glaciated. Neither was the interior of Alaska. It is a remarkable fact that no ice mass covered the lowlands of northern Siberia, any more than those of Alaska, wrote James D. Dana, the leading American geologist of the last century. In northern Siberia, on the polar islands in the Arctic Ocean, spires of rock were observed that would certainly have been broken off if an ice cover had moved over these parts. Bones of Greenland reindeer have been found in southern New Jersey and southern France, and bones of Lapland reindeer in the Crimea. This was explained as due to the invasion of ice and the retreat of northern animals to the south. The hippopotamus was found in France and England, and the lion in Alaska. To explain similar occurrences, an interglacial period was introduced into the scheme. The land was warmed up, and the southern animals visited northern latitudes, and since the change from one fauna to another took place repeatedly, 4 glacial periods with 3 interglacial were generally counted, though the number of periods is not consistent with all lands or with all investigators. But why the polar lands were not glaciated during the Ice Age has never been explained. Greenland presents still another enigma in the preceding formations, those of the Territory Age. In the 1860s, O'Hear or Zurich published his classical work on the fossil plants of the Arctic. He identified the plant remains of northern parts of Greenland as magnolia and fig trees, among other species. Forests of exotic trees and groves of juicy subtropical plants grew in the land that lies deep in the cold Arctic and is immersed yearly in a continuous polar night of 6 months' duration. Corals of the polar regions. Spitsbergen in the Arctic Ocean is as far north from Oslo in Norway as Oslo is from Naples. Hare identified 136 species of fossil plants from Spitsbergen, 78 degrees 56 north latitude, which he ascribed to the Territory Age. Among the plants were pines, firs, spruces, cypresses, also elms, hazels, and water lilies. At the northernmost tip of Spitsbergen archipelago, a bed of black and lustrous coal, 25 to 30 feet thick, was found. It is covered with black shale and sandstone encrusted with fossilized land plants. When we remember that this vegetation grew luxuriantly within 8 degrees 15 of the North Pole, a region which is in darkness for half of the year and is now almost continuously buried under snow and ice, we can realize the difficulty of the problem and the distribution of climate which these facts present to the geologist. There must have been great forests on Spitzbergen to produce a bed of coal 30 feet thick. And even if Spitzbergen, almost 1,000 miles inside the Arctic Circle, for some unknown reason, had the warm climate of the French Riviera on the Mediterranean, still these thick forests could not have grown there, because the place is 6 months in continuous night. The rest of the year, the sun stands low over the horizon. Not only fossil trees and coal, but corals, too, were found there. Corals grew only in tropical water. In the Mediterranean, in the climate of Egypt or Morocco, it is too cold for them. But they grew in Spitzbergen. Today, large formations of coral covered with snow can be seen. It does not solve the problem of their deposition if they were formed in an older geological epoch. At some time in the remote past, corals grew and are still found on the entire fringe of polar North America, in Alaska, Canada, and Greenland. In later times, territory fig palms bloomed within the Arctic Circle. Forests of Sequoia gigantea, the giant tree of California, grew from Bering Strait to north of Labrador. It is difficult to imagine any possible conditions of climate in which these plants could grow so near the pole, deprived of sunlight for only months of the year. Not unless it's going around a brown dwarf or a red one. It is usually said that in ages past the climate all over the world was the same, or that a characteristic of the warm periods, which have formed the major part of geological time, was the small temperature difference between equatorial and polar regions. To this, C.E.P. Brooks, in his book Climate Through the Ages, says, "So long as the axis of rotation remains in nearly its present position relative to the plane of the Earth's orbit around the Sun, the outer limit of the atmosphere in tropical regions must receive more of the Sun's heat than in the middle latitudes, and in the middle latitudes more than in the polar regions. This is an invariable law. It is much more difficult to think of a cause which will raise the temperature of polar regions by some 30 degrees Fahrenheit or more, while leaving that of the equatorial regions almost unchanged. The continent of Antarctica is larger than Europe, European Russia included. It has not a single tree, not a single bush, not a single blade of grass. Very few fungi have been found. Reports of polar explorers indicate that no land animals larger than insects have been seen, and these insects are exceedingly few and degenerate. Penguins and seagulls come from the sea. Storms of great velocity circle the Antarctic most of the year. The greatest part of the continent is covered with ice that in some places descends into the ocean. E.H. Shackleton, during his expedition to Antarctica in 1907 to 1909, found fossil wood in the sandstone of a moraine at latitude 85 degrees 5, and he also found erratic boulders of granite on the slopes of Mount Erebus, a volcano. Then he discovered 7 seams of coal, also at about latitude 85 degrees. The seams are each between 3 and 7 feet thick. Associated with the coal is sandstone containing coniferous wood. Antarctica, too, must have had great forests in the past. It often appears that the historian of climate has chosen a field as hard to master as it is to square the circle. It seems sometimes that the history of climate is a collection of unsolved, even unsolvable questions, without drastic changes in the position of the terrestrial axis, or in the form of the orbit, or both. Conditions could not have existed in which tropical plants flourished in polar regions. If anyone is not convinced of this, he should try to cultivate coral at the North Pole. Whales in the mountains. In bogs covering glacial deposits in Michigan, Skeletons of 2 whales were discovered. Really? Whales are marine animals. How did they come to Michigan in the post-glacial epoch? Whales do not travel by land. Glaciers do not carry whales, and the ice sheet would not have brought them to the middle of a continent. Besides, the whale bones were found in post-glacial deposits. Was there a sea in Michigan after the glacial epoch only a few thousand years ago? In order to account for whales in Michigan, it was conjectured that in post-glacial epoch the Great Lakes were part of an arm of the sea. At present, the surface of Lake Michigan is 582 feet above sea level. Bones of whale have been found 440 feet above sea level, north of Lake Ontario. The skeleton of another whale was discovered in Vermont, about 500 feet above sea level, and still another in the Montreal, Quebec area, about 600 feet above sea level. Although the Humphrey whale and beluga occasionally enter the mouth of the St. Lawrence Seaway, they do not climb hills. To account for the presence of whales in the hills of Vermont and Montreal at elevations of 500 and 600 feet requires the lowering of the land to that extent. Another solution would be for an ocean tide carrying the whales to have trespassed upon the land. In either case, Herculean force would have been required to push mountains below sea level or to cause the sea to erupt. But the later explanation is clearly catastrophic. Therefore, the accepted theory is that the land in the region of Montreal and Vermont was depressed more than 600 feet by the weight of ice and kept in this position for a while after the ice melted. But along the coast of Nova Scotia and New England, stumps of trees stand in water, telling of once forested country that became submerged. And opposite the mouths of the St. Lawrence and the Hudson rivers are deep canyons stretching for hundreds of miles into the ocean. These indicate that the land became sea, being depressed in post-glacial times. Then did both processes go on simultaneously in neighboring areas? Here up, there down, a species of territory whale, Zelugodon, left its bones in great numbers in Alabama and other Gulf states. The bones of these creatures covered the fields in such abundance and were so much of a nuisance on the top of the ground that the farmers piled them up to make fences. There was no ice cover in the Gulf states. Then what had caused the submergence and emergence of the land there? The ocean coast, not only of the area covered by ice, but all the way from Maine to Florida, was at one time submerged and then uplifted. Reginald A. Daly of Harvard wrote, "Not long ago, in a geological sense, the flat plain from New Jersey to Florida was under sea. At that time, the ocean surf broke directly on the old Appalachian Mountains. The wedge-like mass of marine sediments was then uplifted and cut into by rivers, giving the Atlantic coastal plain of the United States. Why was it uplifted? To the westward are the Appalachians. The geologist tells us of the stressful times when a belt of rocks extending from Alabama to Newfoundland was jammed, crumpled, and thrust together to make this mountain system. Why? How was it done? In former times, the sea flooded the region of the Great Plains, from Mexico to Alaska, and then withdrew. Why this change? In Georgia, marine deposits occur at altitudes of 160 feet, and in northern Florida at altitudes of at least 240 feet. Walrus is found in Georgian deposits. Pleistocene, Ice Age, marine features are present along the Gulf Coast east of the Mississippi River, in some places at altitudes that may exceed 200 feet. In Texas, mammalian land animals of the Ice Age were found in marine deposits. These areas were not covered by the ice, which, advancing from the north, reached only as far as Pennsylvania. A marine deposit overlays the seaboard of the northeastern states, and the Arctic coast of Canada. In this deposit, walrus, seals, and at least 5 genera of whales are found. Marine deposits of land identified with both glacial and interglacial ages, or containing animals of Arctic and of temperate latitudes, exist along both Arctic and Pacific coasts in places extending more than 200 miles inland. The change in land elevation in the region previously covered by ice is ascribed to the removal of the ice cover that weighed down the Earth's crust. But what changed the elevation of the other areas outside of the ice cover? If the land slowly rose when freed from the ice and carried the bones of whales to the summits of hills, why did the neighboring land subside miles deep, as the undersea canyons indicate? Daly concluded, the Pleistocene history of North America holds 10 major mysteries for every one that has already been solved. End of chapter.